Proposition 2. Proposition 2 states that to place at a given point as an extremity a straight line equal to a given straight line. Basically what this is asking for is if we have 2 points, A, B, which define a line segment, we want to be able to, having a third point, let's call it C, duplicate this line segment. We want to be able to make a line segment such that AB can be congruent to CD. Now you might think that's pretty easy, but this is actually a very involved piece. You might say initially that, hey, if I just take my compass and I put it here at point A, and I put the second part of this here at point B, and I just have from this point C, if I just copy that, voila, I've done it. I've duplicated this line. And to be honest, in most situations, that's exactly what we're going to do going forward. But first we're going to prove, using our postulates and our previous proposition that we just showed that we can, in fact, duplicate lines in our geometry without this method. All right, we have to first show that it's possible to do this. So, this is going to be a rather long proof. I'm going to do the diagram, and then I'm going to show you step by step how we justify what the diagram shows. Let's begin. Consider for a moment that we have a line, and this is going to be the line that we want to duplicate, BC. All right, so we have a line segment BC, and we have a point not on that line. We will call that point A. First thing we're going to do is I'm going to connect A and B together. And next, I'm going to create an equilateral triangle. I'm going to label this point D, because we already have C here. Now, I could have just shown you how to create an equilateral triangle again. Instead, I'm just freehanding it here. You can imagine, though, if I wanted to, I could take out my compass. I could map out exactly where this point D is. We showed it was possible in proposition 1. That's why we're able to do it here. There, we have an equilateral triangle, ADB. Okay? Note that AB is congruent to BD, which is also congruent to DA. All right, let's continue. We're going to take this here, VC. I'm going to create a circle with BC as the radius. I'm going to freehand it. Now, if you don't have a compass, or you don't like using a compass, now's as good a time as any to test your circle drawing skills. As you can see, mine are a little wobbly, but we'll hopefully get better as we go along. Now, we have the following. We have a circle with BC as the radius. Next, we're going to go ahead and we're going to take the line DB, we're going to extend it outward. We're using postulate, not postulate, we're using actually, yes, postulate 2 here. Postulate 2 to extend any line as far as we want. Now I've created some rays coming off from D. At the very end here, I'll just label this as point F, and over here I'll label this as point E. Now, the intersection between this circle and this line here, this line DF, we're going to call that G. It is unnecessary at this point to label this intersection here. That will not come into play, so we won't touch it. There is a point there. You could call it whatever you want. I'm not going to worry about it for now. So, this is a circle with radius BC, or a radius of BG. So let's note that this line and this line are equal. BG is congruent to BC. Okay? Next, let's create a circle with radius dg. You can see we have an even larger circle encompassing everything now. Right? Looks like the circle skills are either getting better or worse. I can't tell which. Maybe you can. Okay, we're almost done. Let's label the intersection down here between DE and this circle as point L. Okay. Note that DG is congruent to DL. All right. We have everything we need now in order to actually find a line that is congruent to BC, starting from point A. Take a moment, take a look at it, see if you can figure out where we're going to go. We want to find a line, and it's always, you can always, whenever you're doing a proof, you can start at the end and try to work your way backwards if you're ever getting confused, just as much as you can start at the beginning. But we're trying to find a line such that BC is congruent to some line that contains the point A. All right? And we're just going to put a question mark there. We're not sure yet. Well, let's take a look at what we've got. Would you say that dA plus AL, dA plus AL, these segments combined, would that be equal to DL? Would that be congruent to DL? It is. Moving forward, could we say that DB plus BG is congruent to DG? Are these segments, this segment here plus this segment here, well, that should be equal to the whole segment. And we said that about this other segment too. Is this segment plus this segment equal to the whole segment? The answer is yes. All right. Let's rearrange things here a little bit. Let's use our basic laws of algebra and start doing some stuff. Give myself some more room. How about, well, AL, let's subtract dA from both sides of this part here. It'll be more apparent in a section Y, but if we subtract dA from both sides, we have AL is congruent to DL minus dA. Something wrong with that? We can subtract line segments from one another. Let's do the same thing here. For this, BG, let's subtract DB from both sides. BG is congruent to DG minus DB. All set with that? If we take this segment, and subtract this segment, we get this segment. Same here. All right. Well, I'll say we're just actually almost about done. Take a look at what we have. DL by this part here is congruent to DG. So these two things are equal. All right? DL and DG are the same thing. Likewise, DA and DB are also the same. Do you see where, though? Take this here. DB is the same thing. Segment DB is the same thing as segment DB. DB and BD. Same thing. We just wrote them a little differently. So that and that is congruent to segment DA, which is this here. So what we have here is the same thing. DL minus DA is equal to DG, congruent to DG minus DB. That must mean that AL is congruent to BG. Well, actually, take a look at what we've got. BG, that's also congruent, per this step here, to BC. And now we find that we actually have 3 segments that are equal to our original. All right, BC is what we started with. We wanted to find a segment starting with A that is congruent to it, and we in fact found 2. We actually have AL as a segment, and we also have BG as another segment that is congruent to it. That is proposition 2. Thank you.